Hello everyone and welcome to our second PTP Track Hound video. Today I want to show you how you can use PTP Track Hound on your microSync time server. Since the release Meinberg OS 2024.12, you can now run PTP Track Hound directly on your PTP capable ports of your microSync. This has a couple of advantages, as you can now use a PTP port that is already connected to your network, and you can immediately see the time receivers or at least the top level boundary clock of your network by capturing the PTP traffic coming from the boundary clock to your time server. We also give you a free capture license for PTP Track Hound if you already have a microSync time server, so that you can use the microSync as a remote capture tool to capture PTP traffic in a remote site and then forward all the captured data to a central PTP Track Hound running a professional license. Okay, let's have a look at the microSync web interface first. So I log in with the default microSync user credentials, and now I can see that this box is currently logged to GNSS and it already runs a PTP master on port LAN 2.0. A couple of more details can be found on the PTP state page. To enable PTP Track Hound on this box, we can now go to Configuration and then PTP, and a new menu named PTP Track Hound will appear. By clicking on PTP Track Hound and then enabling the capture interfaces LAN 2 and LAN 3, the PTP Track Hound service will be started and the traffic coming in on these ports will be captured, and PTP Track Hound will analyze it and show you the picture of your network. If you have a professional or a basic license, you can also configure this via the microSync web UI, and it will automatically be applied as soon as the service is started. So now I click Save, and it will take a couple of seconds and then the Track Hound service will be started. By switching to the state page, you can now also see that the PTP Track Hound service is running, in which version it is running, and that already 2 PTP scopes, 9 devices and 9 instances have been detected. We can also have a look into the running captures and can see what's happening here right now, and we can also have a look at the packet statistics so that you can see the total amount of packages that have been captured and also the amount of packets per second that are being captured. So if I now scroll back to the top of the page, you can see that there's also a button which is named Track Hound App, and this button will lead me directly to the Track Hound, which is actually the IP address of the microSync/Track Hound. So now I can log in to the Track Hound on the microSync with the default credentials Track Hound and Woof, and it will show me the first picture of what's happening on LAN 2 and LAN 3 on the microSync. Of course, as with all the other Track Hound services running on other devices, you can have a look into the traffic, you can get an overview of the scopes that have been detected. You can see that by assigning segment IDs to LAN 2 and LAN 3, the traffic is already divided into 2 segments. In the LAN 2 segment, you can see that there's SEMTI ST2059-2 traffic coming in. This microSync is actually running as a time transmitter for the SEMTI profile, and there's a number of time receivers synchronizing to this box. On LAN 3, we have a default end-to-end 1588-2008 network, where another Meinberg device is a grandmaster, and there's also a time receiver from another box. So what we can do now is we can use LAN 3 for measurements, as we now have an already GNSS synchronized network interface. So we can use the hardware timestamps of LAN 3 to measure the end-to-end default 1588 network. So as you can see here, capture is enabled on LAN 3 and it is assigned to segment 1. And we can now enable capture time offsets to measure the accuracy of the time transmitter in the network, and we can also enable NetSync monitor to measure the time receivers in the network. So I can now enter the IP address of the time receiver we have in that network, and I set the interval to 1 so that it will be requested once per second. By applying the configuration and then going back to the scopes page, we will immediately see the capture time offset, which is just within 240 nanoseconds. As you know already from the first video, the CTO reflects the pass delay, so this is probably the pass delay from us to the Grandmaster. And then you can see for the time receiver, we are measuring that the NetSync monitor offset is around 70 nanoseconds, which is pretty good actually. Okay, on the devices view, as you know it from the previous video as well, you can see an overview of the network. This is the LAN 2 port, so the LAN 2 port is running as a Grandmaster clock to a couple of time receivers. And then we have the LAN 3 port, where LAN 3 is actually running as PTP Track Hound only, and we have another Grandmaster clock from Meinberg and also a receiver clock from Meinberg. In the analysis view, you can then show an overview of the measured offsets and also of the capture time offsets over the time, and you can see how the offsets evolve. Thanks a lot for watching and stay tuned for the next videos. Bye!